Welcome back, Hornets, to Unit 5.2 and Exponential Decay. Now, we're going to still use the same function that we learned in section 5.1, the f of x equals ab to the x, but now we're going to investigate when we have exponential decay. We'll start with an example. A new car that costs $25,000 loses 12% of its value each year that you own it. So the value of the car gets smaller each year. That's what's called depreciation. So let's fill in this chart to see what happens with this value of this car from year to year. We can see that it starts off at $25,000 and then it's going down to $22,000. So we're losing that 12% every year. Or what I like to think about is that if we're losing 12%, and it goes back to my thoughts on the previous lesson, that if we were to multiply something by 1, it would stay the same. If we're losing value, we got to multiply by a number that's less than 1. Well, the question is, how much less than 1? Well, it looks like it's 12% less than 1. So 12% as a decimal is 0.12. So now with depreciation or with decay, we have to subtract. We have to take this 0.12 and subtract 0.12 from that 1 to figure out what our decay rate is or our depreciation rate is. Well, 1 minus 0.12 is 0.88. And that's what we're going to multiply by each time to get from one value to the other. And just to show that that works, let's look at the calculator. And let's take our $25,000 car. And if I multiply that by 0.88, bingo, I get $22,000. Well, let's continue that to try to fill out this chart. If I take that times 0.88, I get $19,360 for the value of the car. And continuing in that fashion, if I take it times 0.88 again, get $17,036.80. $17,036.80. And continuing, times 0.88. Now we'll have to round to the nearest penny here. 14,992. 14,992 and 38 cents. Continuing again, times 0.88. 13,193. Oops. And 30 cents. And one more time, times 0.88. $11,610. Fixed up. And 10 cents. So again, you can see this is a little tedious to continue doing this. But as we see, to get the next table of the value, you take the previous value and multiply by 0.88. And it says again, notice that you subtract 12% from 100% to get the multiplier. Well, again, let's for the equation for the situation, we've got our equation down here, and our A value is still our initial amount. Okay, in our problem, that was $25,000. And now our decay factor is now a number that's less than 1, and that was 0.88. So we look at the initial value of $25,000 for the car. I'm going to multiply that by 0.88 for every year, is what the X is going to stand for. Let's continue to look at some more examples. Okay. China implemented a one-child policy to combat population growth. China's population in 2000 was 1.2 billion people. So you can see years since 2000 is 0, 1.2 billion people. That's our starting value. if the population was decreasing by 1% a year. Okay, so think about that, decreasing by 1% a year. 1% is 0.01. If it's decreasing, we have to subtract that from 1 to get 0.99. That is our decay rate. So to get the next value in the table, you have to take the previous value and multiply by 0.99. So that's what we can do here, is we can take 1.2 billion times 0.99 to get that answer and continue doing that same process, multiplying by 0.99 each time to get that answer. And we go to our calculator, clear it all up, and we can just go 1.2 and just realize that that's in billions. I take that times 0.99, I get 1.188. 1.188 billion. Take that times 0.99. 1.1762. 1.17612 billion. Continue that times 0.99. And from this point, let's just round to the nearest tenth, or nearest hundredth, I'm sorry. Let's go 1.16. 1.16. Take this times 0.99. That'd be 1.15. Take that times 0.99. 1.14. And then take that times 0.99. And that'd be 1.13 rounded. So the equation with the situation, again, realizing that we look at the initial amount, which was 1.2 billion. Remember, that's the label, then be billions. And the decay factor was that what we're multiplying by is 0.99. And that x is to the every year. So if we want to figure out how many people will be in China in 2025, again, this could take a long time and be very tedious to get out to 25, because 25 would be the year 2025. So I think instead of doing ... all the way out to 25, we can now just put that 25 in for the x of that equation. And again, we can use our calculator. And again, remembering order of operations, we've got to do the exponents first. So 0.99 is my base, 25 is the exponent, and then take that times 1.2, and see you got 0.93 billion people. So this would be 0.93 billion. So in other words, about 930 million people. Well, again, to figure out the decay factor from a percent decrease, you have to, again, change the percent to a decimal and then subtract it from 1. Here's another example. Radioactive isotope has a half-life of an hour. So in other words, half of it decays each hour. You start with 2,500 grams of the isotope, so we're starting at 2,500 at time 0. We're going to lose half of it every hour. Half-life of an hour. So from here to here, after 1 hour, I'm going to lose half of that, which is 1250, etc., etc. Keep taking half of that. That'd be 625. Taking half of that, or we can use our calculator too, and just continue that pattern, say 625, and I'm just going to multiply by 0.5 to keep getting the answer. So 312.5, take half of that by multiplying by 0.5, I'm sorry, so 312.5 times 0.5, it's 156.25. Take that times 0.5, 78.125, and again take that times 0.5, 39.0625, 0625. So as we talked about, to get the next value on the table, you take the previous value and multiply by half, or you could say 0.5. The equation then would be starting value 2,500 times 0.5 raised to the x power. So another question is, how many grams do you have after 10 hours? Well, 10 hours, that's what we're measuring by as hours. All we got to do is just go and take and put 10 into that exponent. So again, remember order of operations first. We've got to take the 0.5, that's our base, times our raised to the exponent of 10. That's our exponent. And then we can take that times the 2,500. So we'd have 2.44 grams. All right, let's continue looking at the back side, practice some other ones here. Laptop costs $1,400 in 2004 and depreciates by 15%. So that 15% is 0.15. If you subtract that from 1, you should have 0.85, and that would get our depreciation rate. Yeah, we're starting with $1,400. So if I look at my equation, you're starting with 1,400. Depreciation rate is 0.85 raised to the x. And if I wanted to figure out, I could fill in this table here. You can certainly do that on your own. But I'm looking at to see what is the 15th year. Well, again, just put that in for the exponent to find out. Or I'm sorry, the 2014. I'm sorry, you want to go 10 years past that. So my bad. You want to go 10 years and put that in. So, again, clearing the calculator. Do the order of exponents first. Take 0.85. That's my base. The exponent would be 10. And then multiply that times the initial amount. It would be $275.62. All right, finishing up. Got a few problems here in 4 and 5. We're going to look at which ones show exponential decay. Okay, so exponential decay has got to be a number less than 1. Exponential growth has got to be a number greater than 1 in the b value. So I see here that number there is less than 1, so this has got to be decay. This number inside here is bigger than 1, so that's growth. Number inside there is bigger than 1, so that is growth. Number inside here is less than 1, so that's got to be decay. And lastly, when we're looking at a table here, we want to be able to look at what the initial amount is. So initial amount is when the time is 0. So initial amount here is 7,000 employees. The decay factor, now this is a little trickier to figure that out. We know this is going down, so we want to figure out how much is that going down by. So what I'm going to do is figure out how much it went down by. That's 7,000 minus 6,300 is $700. So if we want to figure that decay factor, we've got to take that difference, that's 700, and divide it by the original amount. We don't necessarily need a calculator here, because this would come out to be 1/10. It's going down by 10% each year. Okay. What is the equation for this situation? Well, again, if we start off, our initial amount is 7,000. Our rate of decay is 10%. Okay, so remember now we've got to change that to a decimal and subtract it from 1. So we get 0.9 as our rate of decay and raised to the x power. And then if we're going to figure out how many employees there are in 5 years, we simply put that 5 in for the x. And we can do the calculator again. And I would take that 0.9 as my base, raise it to 5, multiply it by the 7,000 for the initial amount, and it should be 4,133 if we do normal rounding rules. How many employees we have after 5 years. So as a summary, how do you write an exponential decay equation? F of x equals the initial amount times your rate of decay, raise the power, and again this has to be a value below 1, and do a decrease remember to subtract from 1.